All my IED students, welcome to the first day of online assignments. When we're starting pretty much in class, what we're going to be starting looking at was getting ready for the end of course exams. So my hope is that we get to take these. It's a really interesting 2-day kind of test from Project Lead the Way, drag and drop, pulling everything together. Kind of look what a real interesting future test will look like for you. So one thing we got to go back and look on that we spent a little bit of time at the beginning of the year, but we want to really refresh now, is properties of geometric solids. So this assignment I'm giving you as both the Friday today and the Tuesday assignment. It'll give you some time to look over your notes, work through the problems, use a formula sheet. If we were in class, you'd have 2 days kind of do it, so I'll give you 2 days with this one. So this one here, I'm opening it up on March 20th. I'm going to check the grades on the Learn site on March 27th. So what we're going to do is we're going to read over the property geometric solid notes together. I'll show you again where the finding density problems are, and we'll be able to look at those. And then when you're doing those, we'll kind of remind you again, don't put any units, and we'll remind you about the Learn site itself. So let's take a look at some stuff here. So everything you're going to find is right on the first thing there. So inside the classroom page, there's your video, and I'll have the materials posted once I get this video done of where you need to go and what you need to do. So the first thing we're going to talk about is properties of geometric solids. So a lot of this stuff is stuff you've hit in geometry class. Nothing too new for you, but we'll discuss. So what we've got: solids, three-dimensional objects. Sketch them on a 2D sheet of paper. You got your volume, you got your mass, your weight, density, and surface area. All those different calculations we can use to figure out what type of material it is. Come with us into Principles of Engineering next year. We'll look at materials and how that determines what you're building and how it helps. Volume, the amount of space that that object or that container takes up. We have the cubic centimeter, or the cc, and then we use the cubic inch. Cube has sides of equal length, so the volume of the cube is just s to the third. 444 gives us 64. Rectangular prism, you have your width, height, and depth. Width times height times depth is your volume. Plug them in, plug and chug, you got your volume of that. Volume of cylinder, pi r squared h. Take the circle, put it on top of each other h amount of times. I'm going to work that. And then a cone, pi r squared h divided by 3. Take your known values, make sure you plug it in. Project Lead the Way does a good job of giving you diameters when they go things. We did dimensioning just a month ago, so when they give you the diameter of 1.5, make sure you're plugging in the radius for half of that, so 0.75. Formula sheet, I'll show you where to find it here in a second, but the formula sheet has all those, so you don't have to memorize the formulas at any point. You'll always have those available to look at and use. Mass, the quantity of matter inside of the object. So we have grams and slugs. We have weight, which would be a newton or a pound that we go ahead and use. So that's gravity acting upon that object. So what are we looking at? The weight itself, the formula we're going to look at is the mass times gravity. So for our class, when we're looking at feet in seconds, we got 32.16 feet per second. Object, whether on Earth or on the moon, has the same mass. However, the weight is different because the actual pull on that object is different for us. So there's different ways and different things to work through, different things and different sets to go and think about whenever system you're using. Different things we're going to look at is mass density and weight density, two different things. Mass density dealing with the SI system, weight density dealing with our system. So when we're doing problems today, we're going to use the weight density for us. So there's just density of different things. You can go and grab most of them around your house right now and see what happens with them. So how do you calculate mass? Well, mass is equal to volume times the density. Density of a lot of the objects is you could just Google search. What is the density of aluminum? Google search will pull up somewhere close to 2.71 grams per centimeters cubed. So you calculate the volume, length times, or width times height times depth. multiply by that type of aluminum, you can go ahead and calculate the mass of that piece. So when you got to do your structures and you've got different materials, you're not just guessing at what the structure weight is. You can actually figure that out due to the type of material and how much of it you actually use. How do you calculate the weight? Calculating the weight by just taking the volume times the density weight. Plug that in, calculate, and be good there. So surface area. Surface area is if you're going to paint an object all around that outside. So it's that area on each one of those sides. Again, I don't think to go over this. You talked about it in geometry or middle school, but this has 6 different sides to it. Each side getting the area of all those, and then just add them up. Surface area, rectangular prism, formula, condensed version of simplified there. Just be able to work through and simplify with those. So plug in, got the 3 different sides, weight, depth, weight, height, depth times height, plug in, calculate the surface area of that rectangular prism there. So go through the work again, plug in, plug in, plug in, plug in, got an answer. Surface area for a cube, all the sides are the same, just take 1, multiply it by 6. Surface area of a cylinder, you have a circle on top, you have a circle on the bottom, and a rectangle wrapped around. So you have 2 circles, 2 pi r squareds, and then you have 2 rectangles. The height times the circumference. 2 pi r is the circumference times the height. So rectangle, length times width, length being the 2 pi r, and the height being then that width. So that's 6 that's going through. So they'll plug all that in for you and get that surface area. So then what are we looking at once we've got all those? So you've got to answer some questions to calculate on 2 different types of objects. So on side of the classroom page, you will see the engineering formula sheet. By clicking and taking it to that, it will take you to the formula sheet. All your solid geometry formulas are here, followed by 1 page down to the left is all of your weight and mass formulas. So what you're going to attack today is looking at, on the Learn page, so it's learn.mywccc.org. When you log into that page, it's the same as what you did with the computer in the classroom. Then when you go ahead, you'll find your weekly review quizzes, and then you'll take in the find density. So the notes I just went over, if you want to look it over again, is there. Otherwise, you got the find density assignment. So when you open that up, I've started already, but it'll say start this attempt, so you'll start that attempt, and you'll go through the different questions. So yours will start you at 1. So as you go and you work through, say you want this one to be 2.32, you can go ahead and check. It tells you right here that answer is incorrect. So you can keep on working on it until you get all of those answers correct. So what we're going to look at then is trying to help you figure out how to go ahead and do some of these together. So if you know what you're doing, go ahead and stop. You can try them. If you need help with the questions or what I'm looking at, you can come back at this point and kind of look at some more stuff. So what I went over is kind of the first 7 questions, because then the back 6 are using the same formulas. That one's left on your own to try to figure out. So that question, I guess I can read it and then bring this video over. Let me minimize this a tad bit. So cast iron. So the first 7 questions all deal with this cast iron cylinder. So it's used in a window to help it counterbalance so the window just doesn't fall right down. There's a weight that keeps it up and steady. So the cylinder has a height of 5 1/4 inches and a diameter of 1.75. The weight density of the cast iron is 259,000 pounds per cubic inches. Use this to answer the following questions. So each question, the first 7 kind of helps with each other there. So what I want to do, I drew myself a picture. Diameter 1.75, height 5.75. I'm going to make sure I put inches in there just to make sure, or like height. And then I've got width. That's diameter, not radius. And then I got the weight densities there. So volume. Volume formula is pi r squared h. So you're just going to plug the r, not the diameter in there, and the h, plug it into the calculator. You can use the pi button or 3.14. Surface area, we know r, half of the 175. We know height. We know r again. And then the weight is equal to, from our formula sheet, volume times density weight, or volume being pi r squared h, substitute that in, times the density weight. So when you're looking to clean the object, you're looking at the surface area. Or if you're looking to paint an object, you're thinking of surface area. So find the surface area of 1 and multiply that by however many things you're looking at. So that's probably question 4, what you're looking at. And then shipping weight. Shipping weight is the weight. So figure out how many total you got to ship and then how much it costs per pound. Question 6 states that the diameter stays the same. The weight needs to be adjusted to 4 1/4 pounds. What's your height going to be? Well, looking at the equation, what has weight and the diameter in it? Well, weight is equal to pi diameter divided by 2, or radius, times the height, times the density weight. So as we write this equation out, we've got weight given to us. We have radius given to us. We don't have height, but we do have the density weight. So I just got to calculate by height, plugging all these guys in. So then 7, we've got to find a new diameter. So we're changing this around to put in a new set of windows. They want the height to be 4 1/2, and they want it to be the weight of the original. So whatever answer you got for 3, you're going to use down here. So what uses height and weight to find diameter? Same equation we looked at before. Weight is equal to pi r squared h times the density weight. What do we know? We know weight from the original, the answer for number 3. We're trying to solve radius. We know height. They told us to change it. We know the density. We're not changing the material, so the density stays the same. So we solve for r by dividing everything to the other side. So weight divided by pi h density weight. Take the square root of both sides. We got radius, but then what are they looking for? They're looking for diameter. So make sure you take that radius and turn it into diameter before you check that answer on that one. Any questions? I'll be available. Email. Quickest response is between about 7:15, 10:15 every day. Anything after that, I will try to be around and answer you quick as I can. But like you guys, there's a lot of stuff going around, so I'll help you when I can. So you have until the 27th to finish up these 13 questions, look at the notes, and work through that. Good luck. Hope to hear from you soon. Stay away from people. Bye.